Hello GATE aspirants, welcome to part 4 of GATE Mathematical Physics series. Question number 1. F of x is a symmetric function of x, that is f of x is equal to f of minus of x. Then in general the Fourier series of the function f of x will be of the form. Now function f of x in Fourier series form is written like this: a naught plus summation over n running from 1 to infinity a n cos of n pi x by L plus bn into sine n pi x by L. Now here bn is equal to 1 upon L minus L to L f of x into sine n pi x by L dx. Now here it is given that the function is even function. This means the function is even function and sine function is an odd function. So this is multiplication of even and odd function. So this integral will give us 0. That means all the b coefficients will be 0. That means f of x will be equal to a naught plus summation over n a n cos n pi x. So option B is correct. Next question. In the most general case, which one of the following quantities is not a second order tensor? Now stress, moment of inertia and strain all are tensor quantities. Only pressure is a scalar term. So option D is correct. Next. For a scalar function phi satisfying the Laplace equation, del phi has. Now if it is a scalar function which is following Laplace equation, and Laplace equation is del square phi is equal to 0. This is equal to del dot of del phi is equal to 0. So this is divergence of del phi. So divergence of del phi is equal to 0. And curl of divergence is always 0. So curl of divergence of phi is always 0. So it is having 0 curl and 0 divergence. Which of the following pairs of the function f of t and its Laplace transform is not correct? So here f of t is given and corresponding Laplace transform is also given. Now first one is delta of t. So if we have delta of t minus c, then it is e raised to minus c into s. Now here if we compare, c is equal to 0. So this will be e raised to minus of 0. So that is 1. So option 1 is correct. Second one is 1 and its Laplace transform is 1 by s. So this is also correct. Next one is sine of kt. So sine of kt is a upon s square plus a square. So here we have a in numerator. So here it will be k upon s square plus k square. So this is wrong. Here it should be k. Then we have t raised to n into e raised to at is equal to n factorial upon s minus a raised to n plus 1. By comparison we see that n is equal to 1. So this will be 1 factorial, that is 1 upon s minus a square. So option D is also correct. So here the one which is wrong is option C. Next, if a bar and b bar are constant vectors, then del of a bar dot b bar cross r bar is. Now we have del of a bar dot b bar cross r bar. So this is a triple product which can be written as b bar dot, then we have r bar cross a bar. Or this can also be written as del dot of r bar dot a bar cross b bar. Now a bar cross b bar is a constant vector because it is product of two constant vectors. So let it be f bar, which can be written as f naught x cap plus f naught y cap, or we can use different here, f1 x cap, f2 y cap plus f3 z cap. So this is a constant vector. Now we have r bar is equal to x cap plus y cap plus z cap. So let us consider this dot product. So r cap dot f cap is equal to f1x plus f2y plus f3z. So divergence of it, so that will be, we are taking gradient of it, so this will be gradient of this r bar dot f bar. So this will be f1x cap plus f2y cap plus f3z cap. Now this is again f bar, so this is equal to f bar. So that means del of r bar dot a bar cross b bar. So I am putting the value of f bar again, that will be equal to a bar cross b bar, and which is the same thing as this. So answer B is correct. Next question. Gamma of n plus half is equal to. So here we have gamma of n plus half. So this can be written as n minus 1 plus half into gamma of n minus 1 plus half. This can also be written as n minus 1 plus half, then n minus 2 plus half into gamma of n minus 2 plus half, and so on we can continue till we reach half. So this will be, now this minus 1 plus half is minus half, so n minus half, then minus 2 plus half is 3 by 2, so n minus 3 by 2, and so on up to 1 by 2, and lastly we will have gamma of 1 by 2. So this is multiplication of all these terms. So this can be written as 2 minus 1 into upon 2 into 2n minus 3 upon 2, and so on up to 1 by 2, and gamma of 1 by 2 is root pi. So this 2 into 2 into 2 n times, so this will be 2 raised to n, and in numerator we have this, these are odd multiples. So let us multiply and divide by in between even factors. So this will be 2n minus 1. I am multiplying by 2n minus 2 here, so we have to divide also 2n minus 2. Then we have 2n minus 3, and so on up to 1, and we are multiplying by the even factors. So 2n minus 4, and so on up to 2, and into we have root of pi. So this will be equal to, this is factorial of 2n minus 1. So 2n minus 1 factorial upon 2 raised to n, and from all these terms we can take 2 common, and such here such n minus 1 terms are there, so 2 raised to n minus 1 into we have n minus 1 into n minus 2 up to 1 into we have root of pi. So this will be 2n minus 1 factorial into root pi 2 raised to n plus n minus 1, so that is 2n minus 1 into, this is n minus 1 factorial. Now let us multiply and divide by 2n. So 2n into 2n minus 1 factorial upon root pi 2 raised to 2n minus 1 2n into n minus 1 factorial. So 2n into 2n minus 1 factorial is 2n factorial into we have root pi 2 raised to 2n minus 1 into 2. So this is 2 raised to 2n, and n into n minus 1 factorial is n factorial. So finally we are getting option C. Next question. For the function f of z 16z upon z plus 3 z minus 1 square, the residue at the pole z is equal to 1 is. Now z is equal to 1 is a pole of order 2. So residue at z is equal to 1, it will be equal to 1 upon, formula is this. If you want to find out residue at any point A, then 1 upon n minus 1 factorial, then we have dn minus 1 dz n minus 1, then that factor, whatever that factor is, z minus a raised to n into f of z at z is equal to a. So here n is equal to 2, so this will be 2 minus 1 factorial, then 2 minus 1 is 1, So d by dz of z minus 1 square upon 16z upon z plus 3 into z minus 1 square at z is equal to 1. So 2 minus 1 is 1 factorial, so this will be 1 factorial only. D by dz, this will cancel out. We have 16z upon z plus 3 at z is equal to 1. So this derivative will be 16z upon minus of z plus 3 the whole square plus 1 upon z plus 3 into 16 at z is equal to 1. And if you put z is equal to 1, then this is minus 16 upon z plus 1, 1 plus 3 is 4 square 16 plus 16 upon 4. So this is 1 minus 1 plus 3 minus 1 plus 3 and that is equal to minus 1 plus 4 and that is equal to minus 3 plus 3. So answer is 3 and answer given in the answer key is also 3 to 3. Next, the degenerate eigenvalues of the matrix, and this matrix is given. Now we can find out eigenvalues by using characteristic equation, which is A minus lambda I, and this matrix is A, equate it to 0, and then we will get a characteristic equation and the roots of that equation will give us eigenvalues. But for this particular case, we get a cubic equation and solving it will be a lengthy process. So we can go around that by using a fact that trace of matrix A is equal to summation of lambda values. So trace of A will be summation of lambda values. Here trace is 4 plus 4 plus 4. So that means lambda 1 plus lambda 2 plus lambda 3 is equal to 12. Also we have determinant of A is equal to product of lambda I. So lambda 1, lambda 2, lambda 3 will be equal to determinant of it. So let us find out determinant as well. So 4 into 16 minus 1. So minus plus 1, minus 4, minus 1, minus 1 into 1 plus 4. So that is 4 into 15 plus minus 5, minus 5. That is 60 minus 10, that is 50. So that means lambda 1, lambda 2, lambda 3 is equal to 50. And their addition is 12. So we have to find those numbers. Now these are degenerate eigenvalues and their summation is 12. So if I start with 10, so then we have 10, 1, 1. Now addition is 12 but their multiplication is not 50. So let's try next combination. 9 to 1, 9 to 18, this is also not possible. Or 8, 3, 1, or we can check 8, 2, 2. For these cases also multiplication is not 50. Next one 7, 4, 1, 7 4s are 28, or 7, 3, 2, 21 into 2 is 42. Then 6, 5, 1, it is 30, 6, 4, 2. So this is 48. Then 6, 3, 3, 18 into 3, this is also not possible, or 5, 2, 2. 5 5s are 25 into 2 is 50. So this is the case. Also we are asked degenerate eigenvalues. So 5 is the degenerate value. So answer is 5. And answer in the answer key is 5 to 5. So these were all the questions from GATE 2013 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.